Hello, my name is Manny, and I look after the aerospace and satellite solutions business for Amazon Web Services across Asia Pacific. In this session, I chat with two of my colleagues on how Amazon Web Services advances both space missions and health and life sciences. Australia is already remarkably active in its contributions to space life sciences. Work is being undertaken by professional institutions in the areas of space medicine research, education, and practically in the world-leading provision of rural and remote medical care. Government organizations such as the Australian Antarctic Division have a strong track record of polar and extreme environment medicine research and collaboration with NASA in space analog work. Multiple academic and clinical institutions around the country are involved in a wide range of space-related disciplines, including fatigue and circadian rhythm physiology, microgravity and countermeasures, musculoskeletal effects of spaceflight, psychology, and even bioethics. Private industry is already collaborating with international space agencies in the novel use of virtual reality for training and psychological support. So where does cloud fit in? Well, let's ask our industry specialists. Welcome, Julian and Daryl. Let's hear a little bit more about who you are and what you do today at AWS. I'll start with you, Daryl.
Thanks, Manny. It's great to be here. My name is Daryl Shook. I'm a business development manager on the aerospace and satellite team that was formed about 2 years ago. I'm focused on human space exploration initiatives. The reason is my career started over 32 years ago, hard to believe, in Houston at the NASA Johnson Space Center, and I still live nearby there today. For the first half of those 32 years, I had what I'd call the second coolest job to being an astronaut, which was being an EVA or extravehicular activity specialist, an instructor and flight controller in that discipline. While I'm not in the medical profession like many in the audience, I will mention that early on there was an aeromedical side right from the start. I started out managing crew procedures, and my title was very illustrious book manager. That included a procedure called the 10.2 psi cabin. That was a relatively new pre-EVA pre-breathe protocol. It involved reducing the entire cabin pressure of the space shuttle from normal sea level of 14.7 psi to 10.2 psi. And it reduced the time of the in-suit pre-breathe, the time the crew had to spend in the suit before going outside, from 4 hours to more like an hour or thereabouts. I became a certified spacewalking EVA flight controller and instructor. I wrote procedures. I taught the crew how the suit worked and what to do if it didn't work, and everything from classrooms to vacuum chambers. I have to mention also the Neutral Buoyancy Laboratory was a huge pool in Houston that's still in operation today. There was actually a predecessor to that when I got there, which was smaller. VR labs, before VR was a mainstream thing, they were using those, and even things like the KC-135 zero-G aircraft, also somewhat infamously known as the Vomit Comet. I sat for many hours in the Mission Control Center, some of that in the later times in the front room, right behind the flight director in what we called the Capcom, and for quite a few Space Shuttle and ISS space station assembly missions. Hubble Space Telescope repair I worked on a couple of those missions, and assembly missions for the International Space Station that has been permanently crewed for just over 21 years now. I also went on to do EVA operations liaison work in Russia for 7 years, going back and forth there quite a bit, working with the Russian EVA specialist, and I really got a flavor for the international aspect of this. That gave me a chance to work around another spacesuit known as the Russian Orlan, and I got to spend some time in their 1G trainers and even put some time in the water in that suit as well. Medical professionals have been literally right next to me all along. In all those training runs, there was always a doctor or physician of some sort overseeing the runs for the safety of it. In the zero-G aircraft, there were doctors there as well. I relied on their medical expertise, such as the flight surgeon and supporting medical teams. They were always watching things like metabolic rates, EKG, CO2, and just monitoring the overall operation for any health-related issues. So I'm accustomed to working with medical professionals, and I'm honored to be here to talk about AWS today.
Welcome, Daryl. Thank you. What a fabulous background. And we learn so much from you internally, but it's such a pleasure to be able to share this with an external community. Now, I also have Dr. Julian Sham, who's our healthcare lead across Asia Pacific for Amazon Web Services. Julian, would you like to give us a little brief about what you do on a day-to-day basis with Amazon?
Sure, thanks, Manny. I have to admit, Daryl's resume is a very hard act to follow. Kind of literally an out of this world kind of resume. My background is I'm actually based out of AWS's Singapore office, and I cover healthcare for the public sector customers in Asia Pacific and Japan. And I've been in this field for healthcare industry for well over 30 years, 10 of those as a practicing surgeon. And whilst I've been involved in sports medicine, major incident medicine, diving medicine, high altitude medicine, motorsport, Formula One, World Superbike medicine, I've never done space. So this is actually a new area for me, and I'm loving kind of the things that Daryl's just talked about and the things that you're talking about, Manny, as how healthcare can not only be applied to space, but what we can learn from space medicine and apply it to terrestrial medicine. So my customers, predominantly for the last 2 years, are government level, national level, international health platforms like the WHO, a number of different governments, and as I'm sure everybody on the call will identify with, COVID response for the last 18 months, which includes everything from vaccination support with well over 1 billion vaccinations on AWS platforms to the smaller startups that have been doing AI to help doctors and nurses triage and provide care much faster to patients who either are suspected of having COVID or do actually have COVID, but delivering care in the comfort and safety of their own home. So my remit today really is to try and explore what areas obviously our space customers are interested in going to, but then more importantly for my public sector customers, what can we learn from space and bring it to the folks, the everyday folks in rural areas, in outreach areas, that we can learn and take away from how we would deliver healthcare in a very contained environment. So back to you, Manny. Thank you.
Thank you, Julian. So much, such crucial work that you do for our AWS customers across the health sector, and particularly with the last 18 months, like you said, about with COVID. Now, let me start with Daryl, because you're dealing with two very different customers. But space, of course, is the province of dual use technology. And to your point, Julian, whatever we're creating for space will have earthly benefits. So let me start by understanding who our space customers are. Daryl, I'll go to you. Julian's just mentioned he supports a lot of government customers, as well as startups, as well as industry bodies that are generally advancing health tech on cloud. What sort of customers do you support on Amazon Cloud as far as aerospace and satellite segment is concerned?
Well, aerospace and satellite was set up just for that segment of customers that just as it's named. As far as customers go, given my background, I tend to focus more on the customers that have a connection to space exploration. So if it's got humans on board, that's an obvious connection. If it's setting up infrastructure, preparing for humans on the lunar surface, that's also an area. So it doesn't necessarily mean there has to be people. It might be infrastructure to support human space exploration. So the new challenge that and the reason this group was set up was to align AWS cloud services or perhaps influence the develop of new ones to support these exploration efforts. You can kind of look at this in stages. We're already in LEO right now, as I mentioned, 21 years and counting, with a permanent presence of humans and on space station, the International Space Station. So that vehicle is aging. It's not going to last forever, just like anything, and NASA knows that. So sometime in the late part of this decade, it'll probably be time to retire that. So NASA wants others to take its place. We're already there already is a company building a module that will fly to the ISS in 2024. It'll dock there, and that could be the foundation for the next commercial space station that will succeed the ISS sometime at the end of this decade. So we're working closely with them and others like them. There's also, NASA knows they want to build a robust LEO low Earth orbit infrastructure environment around, and so there's something called CLD, or commercial LEO destinations, and that, like I said, seeks to establish a robust economy in low Earth orbit with multiple space stations, where NASA is just one of many customers. teams are already forming, announcing intentions to build these other commercial space stations. Companies are coming together, and you probably read about that in the news. So there's really exciting times ahead, with the space station being up there as long as it has, and folks looking to try to make a commercial venture out of that. So, but and I'll just mention is anywhere humans go, medical support is going to be needed. So, for example, there's already many experiments continuing. Probably some people in the audience will are behind some of those studies, but studying human physiology, biology, and will continue on those commercial platforms, perhaps in a for-profit way. So and so that's kind of in the low Earth orbit side of things, and that's a lot going on there and a lot to come. Of course, people on the lunar going a little further, we probably have heard about Artemis, NASA's program to return the next man, the first woman to the moon, sometime in the middle of this decade. And when that happens, the plan is to stay there for much longer durations and even establishing a permanent presence on the surface. Lots of opportunity there, lots of infrastructure that's being built, maybe power systems, communication systems. So lots of customers in that space as well, and partners. The Lunar Gateway is another element of the infrastructure that will be put in cislunar space, and it's a planned small space station that's going to be in lunar orbit, quite a bit further away than low Earth orbit, intended to serve as a solar-powered communications hub, science laboratory, short-term habitation module for government-age astronauts, as well as a holding area for rovers and other robots. So there's things that actually precede that I kind of want to step back to a little closer to now, and that is when we start setting up infrastructure. NASA has they have a program called Commercial Lunar Payload Service, or we call it CLPS. It's a NASA program to contract transportation services able to send small robotic landers and rovers to the moon's solar polar region mainly, with the goals of scouting out for lunar resources, testing for in situ resource utilization concepts, and performing lunar science to support the Artemis program that will follow. CLPS is intended to buy end-to-end payload services between Earth and lunar surfaces using fixed price contracts, and they've already awarded several of those, and they continue to do those from 14 companies in the cadre. Some of these are small companies, so they don't have the resources, or they don't want to put the attention, and that's where the cloud comes in, and we'll talk about that. But looking further out, there's deep space exploration. That's where things get even more challenging. The Mars being the ultimate goal, the moon being a kind of a test bed, if you will. And so we'll be supporting that as well, just as we have in the past with JPL's Curiosity missions and others.
Okay.
Back to you, Manny.
That's a pretty deep and encompassing view of from Earth to Leo to way beyond cislunar and even deeper space. Let me bring us back to Earth just for a moment to learn from Dr. Shams what we've actually done in the context of human health monitoring, either through the pandemic or through the variety of different ways that cloud solutions have been deployed for the health sector to look after population health.
Brilliant. Thanks for that, Manny. So prior to COVID, as I mentioned, a lot of my customers are public sector customers, including hospitals. So prior to COVID, this is very much your typical hospital IT systems and patient data, looking at population health trends, hosting on cloud, with a bit of a genomics thrown in for interest as people start talking about personalized medicine. With the onset of COVID, however, this actually turned the needs of our customers and the world at large into really a very data hungry and insight hungry area where the ability to deploy and scale those systems beyond the four walls of a hospital, connecting patients with doctors, expediting diagnostics, things like COVID tests, X-ray, CT scans, and genomics in order to be able to do sequencing of the COVID virus, all in the name of COVID management, meant that on cloud, we've been working with innumerable customers globally with the vast data lakes, enabling to do remote working, remote patient monitoring, and use of video consultation for telemedicine. So in providing these kind of touch point services where I can provide you a device so I can keep in touch with you, or I have an ability to access that data from an area where that is not within my office, in addition to providing that clinical support, all sorts of artificial intelligence and machine learning models have been deployed to assist clinicians diagnose or look for COVID, whether it's on X-rays, CT scans, looking for the variants and G sequencing, being able to diagnose COVID with gene sequencing much faster than it was done before. I think when we first started, it was taking a week to get those sequences back. Now you're talking minutes, literally, of getting a COVID positive or negative diagnosis back. But more importantly, scaling it and making it as cheap as possible. So what COVID demonstrated is how cloud hosting could speed up access to information and much needed capability. So even somebody in the outskirts of a rural region, as long as they had an internet connection, could actually make use of COVID detection capabilities. Now, space, for me, we're starting to come into this area in terms of how to strengthen, automate, and design robust health platforms that monitor, diagnose, and eventually treat in a very closed and highly regulated environment. So if you think of earthbound problems like osteoporosis in older people, obviously in space, osteoporosis because of low gravity is a very similar a problem. But how do you learn? How do astronauts and obviously space programs deal with osteoporosis of astronauts coming back to ground? Can we learn anything from that and apply it to folks here on the ground? So the way I look at it is in the way that F1 racing, Formula One racing, the technologies that made those cars safer and safer, they eventually make their way to family saloons. In the same tradition that space was an early proponent of remote care delivery and concepts, innovations from space medicine can have a huge impact on Earth-based care delivery challenges, hardening those solutions, but also extending those cloud-based high-performance capabilities to both pharma and biotech communities to develop faster, easier, and cheaper ways of diagnosing problems.
I love
Back
that.
to you, Manny.
Yeah, no, I was just reflecting on what you said. So the value proposition for AWS Cloud, it's very similar, Daryl, isn't it, to what we're doing today for our ANS customers, what Julian mentioned around speed, cost of innovation, scalability, and so getting these crucial applications or systems into the hands of builders or service practitioners who are looking after a community of people, whether that's astronauts or folks here on the ground. How do you see that play out for your human space flight programs or potentially customers that we will be working with?
Well, I think a lot of times when I come into contact with folks, now that we've got this group started up, it's important for folks to understand what the cloud is on the highest level and how it helps our customers. A lot of people think AWS is a place to host websites or store their data. That's true. It can do both of those things, but it's really a whole lot more than that. A lot more. The foundational service which AWS started on was storage, and you can provides a way to virtually unlimited storage with 11 nines of durability, highly secure and private. I do want to emphasize that. A lot of people don't realize just how important that is and how secure it is. The users hold their encryption keys and no one else, not even AWS, has access to that data. So access is from anywhere. But there's so much more, 200 services on AWS and more being added every day, every year. So for example, use this if you need a Windows machine in the cloud with lots of memory and performance, you can just spin that up, and you do that. I do that today with workspaces. It's great, and I use it, and it's great. From an enterprise IT picture, rather than have data closet on premises, it costs lots of money and requires dedicated IT support. You can spin up a server of many kinds. There's over 400 different compute instances. You can have 1,000 of these Linux machines in any configuration if you need it. Install and run what you want on them, spin them up, turn them on, use them, turn them off, and pay for only what you use. We've also got managed services, where you don't worry about infrastructure or services; they just work. Recognition is a text-to-speech solution. I'm sorry, it's a imagery analysis solution where you can recognize objects. Transcribe is another where you can convert speech to text. So there's just so much more, and that's really what I want folks to know. I'm just scratching the surface, and hopefully it gives you an idea of just the depth and breadth of what's available. And you can put these all together, just like we say Lego blocks to address what you need. So if there's one takeaway I'd like to get is that the cloud lets you focus, and this will be true to Manny, to get back more to your question, is focus on what you're trying to do in the space medicine field, rather than being held back by not having enough IT resources at your disposal for whatever reason. And one more thing, if you do know, if you've got to be compliant with certain regulations and standards. One thing that comes to mind in the U.S. is HIPAA. I'm sure there's other equivalents to that, but AWS is continuously audited for compliance in that, and relieving you have to worry about that, at least from the IT perspective. So, so just to drill in just a little bit more on space customers and what we might be doing to help them, every one of those 14 companies building these landers has an MCC. They're probably going to need some kind of mission control center. So we're working on cloud-enabled mission operation centers. The old MCC in Houston was it's a big building with a lot of computer equipment, or formerly had a lot of computer equipment, still does actually to this day, but for all these different companies to execute in real time, they're going to need that kind of capability. And so rather than having a very traditionally on-premises and capital intensive, the AWS cloud infrastructure and services can help our customers to build a hybrid or cloud native solution. So, and as I mentioned, the 14 companies doing those task orders, they're small companies. They're still working on winning task orders. They can't stand up a bunch of hardware and a lot of capital expenditure to do that. So, great example there. Folks might have heard about Ground Station. That's another area that we can help space customers. That was kind of our first foray. It actually preceded the Aerospace and Satellite Group, and it's a space-specific offering. It came about a year before Aerospace and Satellite. Every orbiting asset needs connectivity to the ground, and so that solved a major infrastructure challenge, offering Ground Station as a service, pay as you go, with per minute pricing, and it goes right into the AWS cloud for immediate processing and transmittal all over the world from 9 sites, placed right on our data centers that are spread of the 25 regions around the world. And that's enabled things like entities like universities and small companies to connect to their small sats or other assets that are in space. So finally, there's a lot of interest around about in-space autonomy, and or there's a need for that, and space vehicle edge processing and storage. So as we move towards deep space exploration, we already realize that the bandwidth is going to be limited, but there's also one thing that's going to really make it a challenge, and that's latency. Folks may not realize, maybe they do. One-way latency to the moon is 1.2 seconds. That might be tolerable, for a conversation. It's a little slow, but when you start getting into the Mars regime, you start talking about several minutes. So having AI and machine learning running on the edge, disconnected from a real-time connection, is a capability that we were sort of anticipating. There's also some work being done on the ISS with a portable ultrasound device. Folks might have heard about that, but there's an example of a diagnostic instrument that's being tested on the International Space Station today. So, commercial space stations that they're building, they're going to need to be more of money-making, interest. So, having them be self-tending and requiring less maintenance will be enabled by having more of a AI/ML automated type of health, vehicle health monitoring capability. So those are some of the ideas.
Thanks, Daryl. I want to recap some of that for the audience in case they're hearing it for the first time. But I think it's the bottom line here is cloud takes away the heavy lifting. So you don't have to focus on the infrastructure, the high performance computing, the machine learning. And I guess what I want to, and it takes care of things like compliance, the regulatory regime that Daryl mentioned. Julian, I'll get you to comment a little bit about that in terms of how we may have already, or we are already helping our health customers abide by regulatory requirements, but at the same time overcome these infrastructure challenges, particularly as far as remote medicine. I mean, Dara talked about connectivity, the lag, the latency. How have you helped customers on planet Earth to overcome some of those obstacles and challenges, so we can understand how to translate maybe some of that same learnings for our lower Earth economy or even deep space economy?
Sure. Thanks, Manny. Thanks, Daryl. I mean, what Daryl's just mentioned, I often say to my customers in terms of let AWS help you do the technology so you can focus on the science. You know, you should be spending all your time on what your researchers are best at, or delivering care, and focus less on the technology. But in terms of the challenges of space and what we're doing here, whether you're in a deep space exploration or low Earth orbit, or you're in a very rural area, I guess the challenge is still the same. You're in an environment that's a closed system. So in the same way that early adventurers to the North and South poles were limited to what equipment they were carrying with them and the knowledge they had within their groups, it's the same challenge. How do you get doctors and nurses kind of going to rural areas in the same way you can't just fly somebody up to space if somebody requires an appendix operation? So I know one of the early questions posed by NASA was, could the human body function in outer space? We know it can. But the things like monitoring the anatomy, your physiology, Daryl mentioned kind of musculoskeletal kind of reactions to gravity, and other factors means that the ability to use remote monitoring technologies for vital signs, for breathing, for oxygenation is vital. But we need to make that as unobtrusive as possible. And that's probably the most highly desirable point. So if you think of somebody who's in an intensive care bed, they've got wires and they've got tubes coming out of everywhere. And that's probably not tenable either in a rural area or in space. So things like Internet of Medical Things technologies allows for the capture of that patient or astronaut generated data into cloud platforms like AWS Greengrass, which does a lot of our IoT interfacing, the ability to do real-time analysis of that data coming in, leveraging tools, services like AWS's SageMaker Studio, which is our AI ML tool to simplify AI development. In order to be able to assist you checking aberrations to the norm, are thresholds being breached, alerting not only aerospace physicians of possible complications early, but also a doctor who may be in the academic teaching center, which is a 2-hour drive from where you live. A great example is Care Monitor. They're a health tech startup in Sydney, Australia. AWS and kind of COVID allowed them to pivot their solutions to manage COVID positive patients in their own home. So the premise here was patients who weren't sick but were COVID positive needed to quarantine in an environment that was safe. But you could provide them the medical devices, quarantine them at home, and the same technologies we're actually using today to record this video conferencing, Amazon Chime, was integrated into their platform in less than 1 week. So they are then able to provide a holistic package for patients who not only felt that they had a safe reach out if they weren't feeling well, but the clinicians in the hospitals who were monitoring those patients literally had real-time information and could understand if patients were going off and reach out through video consults to go, are you okay? Do we need to bring you in early? That enabled two things. That enabled the clinicians to focus on the really sick, but it also meant that the beds were freed up for those that are really sick, as opposed to somebody that just was COVID positive. So what we're seeing here is that, these services are hosted on AWS. They're integrated within the AWS ecosystem because all of our services are built so that they integrate tightly. And as things like deep space explorations become a possibility, the ability of those communication channels to maintain real-time connections to mission control becomes challenging. Daryl mentioned it before in terms of latency and performance. So things like AI and ML that we're able to develop now, especially in kind of a space program where you need to automate that to augment clinician capability on board, you can imagine what that could do in Earth in a rural area for services that are overstretched. In a similar way, in terms of kind of latency, using things like cloud edge technologies so that the sending of data from a space vehicle to Earth, if you could leverage the same things, that would also make signaling and sharing of data amongst different rural areas much cheaper, and people more willing to kind of undertake that kind of next step. And then finally, in terms of what else you could build, Daryl mentioned it in terms of the portable ultrasound machine, diagnostic technologies such as onboard rapid gene sequencing, rapid laboratory tissue testing, your portable ultrasounds or X-rays with AI and ML so that it identifies what could be wrong with a particular scan. Examples beyond, include things like Philips Lumify or Viz.ai that can enable more complicated complications to be spotted much earlier. When you couple that with robotics, robotic assisted surgery, who knows where it may stop. But the important thing here is that the cloud-based technology is there to augment the medical personnel's capability and response options. And then it allows you kind of a shopping list to choose from of what fits best in the environment that you're in. Back to you, Manny.
It sounds absolutely fascinating. And I realize, this is two very deep disciplines coming together. So we could spend, I guess, all day, all week talking about the amazing technologies on both the space side, on the cloud infrastructure side, as well as the medicine and the biomedical side of things. I don't want to hold you up forever. So I think we'll sort of start to wrap, but I want to ask you one question, and it's also to leave the audience feeling inspired, if they haven't already, because there's so much it seems that we can do. We're only limited by literally our imagination at this point. What are you most looking forward to when you think about the confluence of space and medicine, space medicine coming together? You've both been in this sector for many, many years. I'm sure you've got things that make you excited. Daryl, I'll start with you.
Well, as I said, the confluence, as you mentioned, has been ingrained for a long time. The biomedical and the flight surgeon types have always been integrated with the testing. So we anticipate, the crews are going to need healthcare. The tourists that are going to space are going to need that. It really is going to have to be self-contained. And some of the things that Julian's talking about how we handled COVID and managed their healthcare, I think that this is just a natural extension to that. And we'll be, AWS will be part of that infrastructure and the tooling, if you will, both on the edge and on the ground to make that happen. So I'm really excited to be here and to be able to pull a very specific human space element, a very, very cool part of it, into this group, and then working with folks like Julian with such a great background in telemedicine and things that you already mentioned, and some of those other things like F1 racing. Space is just ripe for that kind of collaboration. So I'm really looking forward to the future here.
And you, Julian, what are you most looking forward to?
I think in the healthcare space, when it comes to the pace of innovation and thinking outside of the box, because of the nature of the industry and looking after sick people, I think folks are reticent about reaching out and doing more. So what's great with especially this kind of space medicine area is there's almost no boundaries. We're exploring areas that folks haven't needed to be constrained by before, the sorts of technologies and the sorts of investments and the problems that we could potentially solve with technology for a kind of space problem. I think that just allows people a lot more creativity, the ability to innovate and think outside of the box and not be constrained by earthly bound problems. But on the flip side, knowing that at the end of the journey, a lot of hopefully what we build, that's industrial strength and can, hack it in space, we can bring down to earth and we can really make a difference to challenges either both from equity of care, access of care, but also making care more accessible wherever you are in the world. And, no matter kind of what the challenge might be getting care delivery to you. So I'm most excited about the boundaries and endless boundaries of what we could develop here, bring back to earth, and then just get it out to kind of the general population. So that's me. Back to you, Manny.
Oh, what a terrific note to sort of wrap this session on. Truly, there's no limitations to what we can achieve if we put our minds to this in this particularly exciting sector. The potential benefits to the Australian community and economy from a well-established space life sciences capability within the Australian space industry is going to be enormous in terms of revenue. It's not just going to be an enabler of human space flight missions, but the scientific spin-offs that we can expect will provide substantial economic and public health benefits, like you said, Julian, to Australia through improved healthcare. So With that said, we want to thank you for listening to us. We really enjoyed presenting this session to you. If you're a researcher, an entrepreneur, or a builder looking to explore how AWS Cloud can support accelerate your missions in this particular area, please don't hesitate to reach out to us. We'd be glad to help.